that is at this value of bending stress, my material or the beam will be fail. So I wish you have understood this fundamental very well. Let us we go ahead with the next problem. Number 4 problem. A rectangular beam 200 mm deep and 300 mm wide, which is simply supported over a span of 8 meter. What uniformly distributed load UDL per meter the beam may carry if the bending stress is not exceeds to 120 megapascal? Very good question which has been asked. Let us I'll read this problem once again so that you can understood this problems precisely, that what the things can be asked over here. Rectangular beam, its cross section which is given to us, length of the beam which has also given to us, also the maximum allowable stress is also given to us. The things which can be asked is UDL per meter. So depth of the beam D, that is 200 mm, width of the beam B 300 mm, length 8 meter, F max is 120 Newton per mm square. See the figure. Simply supported beam, length L 8 meter, unknown parameter is of UDL, W per unit length. This 300 mm is the width, 200 mm is the depth. Now, section modulus of a rectangular section is given by the equation Z is equal to BD square by 6. B is 300, D is 200. So 300 multiply by 200 square divide by 6. We got some answer in terms of millimeter cube. That is nothing but it is section modulus. Now, maximum bending moment for a simply supported beam carrying a UDL is at the center of beam. It is given by WL square by 8. Let us be understood these things on the tabletop. Simply supported beam UDL, L is the span, then what will be the reaction? It is nothing but WL by 2. WL by 2. This is the center, then moment at the center is RA into L by 2 minus W into L by 2. This is the load, multiply by half of L by 2. When you resolve this one by putting the value WL by 2 into L by 2 minus WL square by 2, 2, 2, it is 8. And we got the answer WL square by 8. So this is the maximum bending moment which has been taken care at the center. So if you want to avoid this certain steps, you have to remember certain formula which is applicable to a certain cases. So let us come to this PPT. M is equal to WL square by 8. This W unknown is there. L is the 8. So 8 square divided by 8. It is simple 8. 8 W Newton into meter, because L is in terms of meter. So 8 W into 1000, that is the 8000 Newton into mm. Now we know the equation M is equal to F max multiplied by Z. M, that is 8000 W, is equal to 120 multiplied by the Z that has been found out by BD square by 6. By solving this equation, we got W is as 30 kilonewton per meter. 30 kilonewton per meter is our answer. So you just see that how a simple single equation of M over I is equal to F over Y is equal to E over R, or M is equal to F into Z, how it will be simply used to solve a simple problems. Next problem, number 5. A rectangular beam 300 mm deep is simply supported over a span of 4 meter. Determine the uniformly distributed load per meter length of the beam may carry if the bending stress is not exceeds 120 megapascal. The value of I, which has been given to us as 8 into 10 raised to 6 millimeter raised to 4. Think what we can do in this particular problem. So rectangular beam, it's one dimension, that is of depth, which has been given to us. Another parameter, that is the given beam, is of simply supported beam, length 4 meter. The question which has been asked is to find out uniformly distributed load, that is act per meter length of beam. Two additional thing which has been given to us as F max 120 megapascal, 120 Newton per mm square, and the value of I, 8 into 10 raised to 6 millimeter raised to 4. So now what we can do? Now please recall that we have solved the previous problem, that let W is the UDL per meter length over the beam, that is Newton per meter. Then the bending stress will be maximum where the bending moment is maximum. Maximum bending moment for a simply supported beam with UDL is at the center of beam, which is given by an equation WL square by 8. W into 4 square by 8. 2 into W Newton into meter, multiply by 1000, 2000 W Newton into mm. Basic equation, M is equal to F multiplied by Z. So 2000 W is equal to 120 multiplied by, as Z is not directly given to us, so I have to divide into two parts. I by Y max, I is given to you 8 into 10 raised to 6. Divide by Y max, that is 300 by 2. By resolving this simple equation, we got W is as 3200 Newton per meter. So, I wish you have understood clearly how we can solve a problem. So, for any kind of loading, we have to find out the maximum bending moment first. Let's go to the next problem. A square beam that is of 20 mm cross 20 mm in section and 2 meter long is supported at its ends. What does it mean? Supported at its ends means the beam is of given as simply supported beam. The beam fails when a load of 400 Newton is applied at the center of beam. What uniformly distributed load per unit length will break the cantilever beam of the same material 40 mm wide, 60 mm deep and 3 meter long? Very good question which has been asked by this particular problem. Refer the question once again. In this particular problem, the problem which has divided into the two parts. The first, they use the word a square beam, simply supported, and has been told that fails at the load of 400 Newton. Let us come to this particular tabletop. Simply supported beam which has been given to us has been told that at a certain load, the specifically 400 Newton, it will fail, and 2 meter the length which has been given to us, the cross section dimension square, that section is of 20 mm by 20 mm is given to us. So everything which has been given to us, and it's been said that at this load this beam will fail. Next question that has been asked, that for a cantilever beam for a length of 3 meter, for a section of, the section for this is given us as 40 and 60, 40 mm wide, 60 mm deep, UDL is going on, W at what load it will fail. So here two things will be incorporated. First, it has been stated that this beam which has been failed at this much load. So can we find out F max? Yes or no? If we can able to find out F max, then same F max we can apply over here as the beam which is made up of the same material, and we can use this F max to find out the value of W. So the question is that how to find out the F max in this first part. How to find out the F max with the first part. Now see the equation, basic equation. M over I is equal to F over Y. This F is maximum, Y is also maximum, M is also maximum. Now Y max we can found out as is d by 2, 20 by 2, 10 mm. Mx, refer a simply supported beam with the center point load. Formula on this tabletop, WL by 4, I 1 by 12, B D cube, and we can easily found out F max. Come to this particular PPT. So in this particular problem, the maximum stress for the simply supported beam is to be calculated first, as the material of the cantilever is same as that of the simply supported beam. Hence, maximum stress for the cantilever will also be the same as that of the simply supported beam. So, section modulus Z BD square by 6, we know the answer. M is nothing but WL by 4. We got the answer is as 200 Newton into meter. As all the dimensions are converted in terms of the Newton and mm, I have to multiply with the 1000. M is nothing but F max into Z. So by putting this value, we can find out F max as 150 Newton per mm square. Up till now, only the half part of the beam which has been solved. Let us go ahead with the next part. Now let us consider a cantilever beam. W is a UDL per meter run. We know the F max, we know the B, that is 40, D and length. Then section modulus Z is BD square by 6. 40 multiplied by 60 square by 6 as 24,000 millimeter cube. Now for a cantilever beam, important point is this one. Come to this tabletop. For this cantilever beam, what is the value of M max? M max which is taken place at the fixed end.